Okay, guys, I'm going to do the third review session right now, and I'm on page 7, 2D projectile motions. Okay, so here's some concepts we start out with. For a horizontal direction, okay, when I say horizontal, I mean x direction. What is the acceleration equal to? So ax is equal to what? 0. Why? There's no net force in the x direction for a projectile that's in the air, unattached by whatever fired it forward. So that force is no longer pushing it forward. The force, like from the baseball bat or the foot or the gun. So ax is 0. So that's an important point. What does this mean for horizontal velocity? That means VOX equals VFX, and that it stays constant throughout the whole trip. The speed stays constant throughout the whole trip. At least there's two kinds of projectiles, two-dimensional. One that's thrown forward, and right before it hits, it still has the same forward speed as it had at the beginning. Now, that doesn't mean it doesn't speed up. The y component is going to increase. Okay. If I threw something like this, an angle, this is VO, this would be VOX. Anywhere along the trip before it hits the ground, that VX is going to be the same thing as VOX, no matter where it's at. Okay, so that's really an important concept. So what does it mean for horizontal velocity? It means Vx stays constant, no matter where it's at, as long as it's in the air, with no net force. We assume there's no air resistance. What is the acceleration equal to? For the vertical direction, well, we know that. Vy, what is the acceleration equal to? Ay is equal to negative 10. What causes the acceleration? Well, Newton's second law, F net equals to ma. What causes g? Hi, sweetie. The weight. The weight causes g. Okay, so the net force on an object in a vertical direction is the weight. List two assumptions made in the vertical direction for a projectile launched horizontally. So I'm talking about this thing. Okay, we're assuming that there's no drag, air resistance. So that means AX would have to be 0. Also, we assume if it was shot horizontally, VOY is 0. Oops. Yep. VO in the Y direction has no falling speed at the moment. It leaves whatever's projecting it forward. Okay, that's very important. You can't do these problems without knowing that. For project, what to okay, so if I shot something up like this, VO, this is right on your equation sheet. So if I shot it up at some angle, oops, some launch angle, to find the vertical and horizontal components, here's VOX, that's the horizontal component, here's VOY. Okay, the three-finger rule. This is on your equation sheet, though, in one form. VOX equals VO times cosine of theta. Be sure to use degrees. VOY equals VO times sine of theta. That's on your equation sheet. You gotta be able to use it to do two-dimensional angle problems. Problems that go like this, right? They get shot and they go make a parabola. What assumptions can you make for the following situations? Finding the maximum height that the projectile reaches. Well, we can assume that the maximum height right there, right? We can assume that, let's call that VF right there. We can assume that VFY is equal to 0 and that VFX at that maximum height is the same as VOX like we said before. So it does not stop. It does not stop at the top. It keeps on going with the X component that it had at the beginning. Find the total time. Okay, so what can you do? The total time. Okay, what assumptions can you make? Well, T total equals 2 times the time it takes to get to the top. That's the trick. Time for the total trip is twice the time it takes to get to the top. How do you find the speed at the highest point of the trajectory? I kind of just went through that. V at the top is equal to VOX. Okay, VOY is 0. I'm sorry, VFY is 0 at the top. Okay, so we're going to do a problem right now. Okay, so let's draw a picture. So he's going to jump, he's going to run off the board. So dy is negative 23.5, right? The height is a displacement, start to finish. So the excuse me, dx is 10.7 meters. How fast was she moving when she left the diving board? So I'm looking for VO, which is really VOX. So here's the strategy. First, find the time it takes to fall. Okay, so find the time. VOY is 0. AY is 0. DY is negative 23.5. So let's find the time. So D equals VOT. Okay, so D equals VOT plus AT squared over 2. I'm just using the y's. Don't mix up the y's and the x's. Be sure you don't do that. So negative 23.5 is equal to, cuts that out because it's 0. VOY is 0. equals negative 10 times t squared over 2. So that's negative 5. So divide both sides by negative 5. T squared equals negative 23.5 divided by negative 5. The negatives cancel out. So 2.5 divided by 5 is 0.5. I should have known that. Oh, but that's t squared. So t would equal square root of 0.5. So I'm going to square root that answer. 0.71. 0.71 seconds. Now, I had to find that to find her forward speed. So now we're going to do the the x values. So I have dx is equal to 10.7. I have ax equals 0. I got the same time as before for the y values because that's shared. And so I should be able to find the OX because doesn't that equal average BX, right? So, I mean, I can do several things. I mean, BOX equals BFX. That's what I'm looking for. So, since these are constant, I'm just going to call that average VX. So, really all I have to do is average V is D over T. And so that's 10.7. I'm using x values. Dx is 10.7 divided by 0.71. 10.7 divided by 0.71. 15.1. So he's sprinting off that thing 15.1 meters per second. That's what my VOX is. Okay, so same kind of question here, but different different approach. So the car goes like this. So we're looking for dy. So VOX is 2.8 meters per second. DX is 1.35 meters. So I'm going to find time first using my x values because I got more of them. So V equals D over T. Now if you don't want to use that equation, you can use D equals VOT plus AT squared over 2. AX, I'm using the x values. And you know AX is 0. You know AX is 0. So this whole thing's out of there. It's 0. So I'm solving for time. So 1.35 is equal to 2.8 times t. So time is 1.35 divided by 2.8. 1.35 divided by 2.8 is 0.48. 0.48 seconds. Now, why am I finding time when they're asking for the height? Well, I need to find time before I can find anything. So I use the x values because I have more stuff about the x values. Look, more information is about the x values. So now I'm going to use my y values. Let's shrink this down so I got a little more space here. Okay, so now this is the same equation. How about that? So d equals VOT plus AT squared over 2. I'm using my y values now. So VOY is 0, right? That's the assumption. VOY is 0 at the moment. It comes off the ledge there. It has 0 falling speed. Okay, so dy is what I'm solving for. 0 plus negative 10 is ay. The time, that's why we found the time. So you get a negative number because of displacement. Negative 5 times 0.48 squared. 5 times 0.48 squared is 1.15. 1.15 meters. And it's negative, but the height's positive, so that's my answer right there. dy is negative 1.15 meters, or the height is 1.15 meters. Okay, now we're going to do the rainbow kind of problems. Saw a cool rainbow today. It was a perfect rainbow in Dunedin across the sky. Anyway, football player kicks from the tee with an initial velocity of 25 meters per second. Okay, so here we go. So we got angle of 42 degrees, it says. And VO off the foot is 25 meters per second. That's what it tells me. How long is the ball in the air? So that's the time. So on these problems, the trick is to find the time it takes to go to the top and then multiply by 2. So let's do that. It's going to get to the top. So right here, well, first of all, got to find VOX and VOY. So let's do that right here. VOX is equal to VO cosine of theta equals, in this case, 25 cosine of 42. VOY is equal to VO sine of theta. So that's 25 times sine of 42. Let's find those answers. 25 cosine 42. 25 cosine 42. Oops. 18.6 meters per second going downward. I'm sorry, going forward. And the other one, 25 sine of 42. 16.7 going upward meters per second. Okay, so first step you have to do, if they don't give you those values, VOX and VOY, is to find them. Okay, so almost get light color. Okay, so we have to find what the time it takes to get to the top. So let's use our y values. And we got, you know, the fy at the top is equal to 0, right? So let's make this smaller. Okay, so we know VOY now. We have VFY, AY, so we can find time. So AY is negative 10, right? So A equals VF minus VO over T. I'm going to use Y values. So negative 10 equals VFY at the top is 0 minus VOY is, in this case, 16.7 over T. So negative 10T equals negative 16.7. So T, to get to the top, is 1.67 seconds. So how long is the ball in the air? That's the total time. It'd be 2 times 1.67, whatever that is. Okay, so 3.34. That's total time. Okay, so what is the highest point that the ball reaches? That's the dy, right there, the height at the highest point. So about, we have time. Let's see what I have. VOY, I have AY, I have time. So how about D equals VOT plus AT squared over 2? Looks good. Only use the Y values. So dy equals VOY is 16.7 times the time. Don't use the total time. Only use half the time, because that's the time it takes to get to the top. Let's shrink this down. Okay, plus negative 10 is AY times the same time, 1.67 squared over 2. There's no way I need a calculator for this. So don't forget the negative. So let's take care of this. 16.7, oops, 16.7 times 1.67 minus 10 over 2 is 5. Minus 5 times 1.67 squared. Oops. Minus, oh, let's just do it this way. Let's clear that, do that again. 16.7 y times t, 1.67 equals minus 5, which is 10 over 2, times 1.67 squared. I wonder if I have to put that in front of these. I don't know. I don't think so. We'll see. It's 13.94. So that seems reasonable. 13. 4 meters. Just check. 27.89 minus 5 times 67 squared. Yeah, you get the same answer. Okay, how far downfield does the ball land? Okay, we're talking about dx there. We're talking about right here, dx. So I'm using my x values. Ax is 0. Vox is, we already know. We already found it. 18.6. What else? What else do I know? dx I'm looking for. I know the time. Now I'm going to use the full time, right? Because it has to go all the way downfield. Okay, so I know that's 3.34 seconds. And so I should have enough here. D equals VOT plus A. Okay, good. So D equals VOT plus AT squared over 2. I'm using only the x values, right? So that cancels this out because AX is 0. So very simple. dx is equal VOX, which I already have is 18.6 times the total time, which is 3.34. So that comes out to be 18.6 times 3.34 is equal to 62.12. 62.12 meters downfield. Okay, so I'm doing some more, I guess. One more. One more for practice. Okay, so let's see here. Okay, so she's going 65 meters per second. That's my VO. And it's an angle. It's at an angle of what, 22 degrees. Okay, so we have VOX, VOY. Let's find those right now. VOX is equal to VO times cosine of 22. And VOY is equal to 65 times sine of 22. Be sure you use degrees. 60.3 for this one. And then for this one, 65 sine of 22. 24.3. For that one. Okay? First thing you have to do is find the x and y components. So how long is she in the air? So I have to find the time it takes to get to the top. And then I have to find double that time, just like we did before. So let's use the y values because I know at the top right here, v of y is 0. So I can do a equals v of y minus v o y over t. So negative 10 equals 0 minus v o y, which we just found. 24.3 is positive because it's going up, over t. So 10t is equal to 24.3. The negatives cancel out. I just automatically cancel them out. Cross multiplied. Two negatives on both sides cancel out. So t equals 2.43 seconds to get to the top. The total time would be twice that much, which is 4.86 seconds. So that's how long she is in the air. Where's the highest point? Okay, this is the same thing that we just did. Highest point is what? dy. So d equals VOT. What? D equals VOT plus AT squared over 2. We're going to use only y values. So VOY is 24.3 times time it takes to get to the top is 2.43. AY is negative 10 times 2.43 over 2. So let's do the math. .3 times 2.43 minus 5 times 2.43 squared. Oops. So I get 29.5 for dy. 29.5 meters. Okay. How far from launching point does she land? Same thing. dx is a question mark. Use the same equation. dx equals voxt. Okay. You going to bed? No, I'm going to be talking. You don't mind? I'll just finish this one off. Okay, so let's plug our numbers in. Vox is up here, 60.3 times time. Now this is the time for the total trip because it's going all the way down, not just halfway. So that'd be 4.86. Then all the rest cancels out because AX is 0. So 60.3 times 4.86 gives me this 293 value, 293 meters. Okay, so that's all for this video. We just finished one of the tougher units, two-dimensional kinematics. Okay, so I'll see you guys on the next video.